Welcome to Train Signal. You are watching Failover and Failback. In this lesson, I will show you what failover is and how it is different from a recovery test. We'll talk about why failover is an executive decision and not to be taken lightly. We'll also cover the best practices for planning and executing a failover. We'll contrast the capabilities of synchronous replication versus those of asynchronous replication and how you need to think about them in a failover situation. We'll also talk about failback planning for storage and SRM. We'll talk about why failback is another executive decision that cannot be taken lightly. We'll talk about failback to a functional protected site. And we'll also discuss failback after 100% loss of your protected data center. This should be an interesting lesson. I'm excited to get going, so let's do it. What is failover? Failover is that big red button. It initiates a permanent change to the SRM environment and shuts down your production VMs until the failover can complete the recovery. For this reason, failover is an executive decision. It affects your overall business continuity, and there's definitely some risk involved when you shut down your critical business software systems and attempt the recovery of a reconfigured copy of those systems at a remote site. As you can see, there's a few moving parts there, and your business's future is dependent on the outcome. Can you see why testing your recovery plan might be a very critical activity to schedule? A recovery test, however, leaves protected VMs running and boots VMs from a snapshot of a replicated data store. These replicated snapshots, the snapshots of a replicated data store, are cleaned up when the recovery test is done. The following disclaimer would be appropriate for a recovery test. No production VMs were harmed during this test. And that's quite true. So you can do a recovery test whenever you want, and it's suggested that you do them often. Failover, however, is quite a different beast. It is a permanent configuration change. It powers down protected VMs prior to failover. These protected VMs are your critical VMs, otherwise we wouldn't be protecting them, so it's a big deal. It also recovers these VMs permanently to the recovery site. Now, yes, we can do a failback, and we'll talk about failback later, but for all intents and purposes, it's a permanent recovery. So there's a definite business impact to initiating a failover. In a failover, the replicated data store is transformed into a live production data store, storing the production VMs. It's this characteristic of a failover that makes it most important to take the decision to failover very seriously, and that is the production data is moved and operation is moved to that recovery site. There are some good technical best practices as well as procedural best practices surrounding SRM failover. The first involves good communication with the executive leadership that's ultimately responsible for making this business critical decision to fail over their systems. It's important to involve these leaders early so that they can help make decisions on the consequences surrounding a failover. I think this even applies to the way early stages of the initial design and configuration of SRM as well. At least it can't hurt. Communicating clearly and promptly the need for testing and communicating the outcome of those tests is also a good way to get their buy-in and help train them on the consequences of a failover and how they need to go about thinking about it. This ties very closely to the business continuity practices within your organization. And then when that disaster event actually happens, again, open up those lines of communication as early as possible so that when it's time to pull the trigger, everyone has had a chance to weigh the alternatives and they're prepared to make an informed and practiced response, one that you've practiced every time you've tested your DR. The next best practice is that of testing. If you have ample time or you have a slow-moving disaster or one that you have plenty of notice, run a recovery test. You should be doing this on a regular basis anyway, but changes could have happened since your last month's DR test, or even last week's DR test. If you have time to run the test and see if there's anything that needs to be fixed, go ahead and do it. Then lather, rinse, and repeat until you have an error-free recovery or until that deadline hits and you don't have any more time. One of the greatest benefits of an SRM system is that you can run tests frequently as you need to. The next best practice that you need to have under your belt is knowing what type of storage replication you have. In this crucial time, it's important to know what type of storage replication you have as well. And that's my next best practice that I want to talk about. If you have synchronous replication, you don't have to worry as much about whether you're going to lose data or not because the replication is in real time. So when you initiate a failover, it'll shut down virtual machines and stop I/O to those protected data stores. That in turn gets replicated in near real time to the recovery site. So you end up with a recovery point objective, or RPO, of 0 seconds. That is, there's no data loss. And your VMs will be in a pristine, ready to boot condition at the recovery site, as long as you got a graceful shutdown in time. Now, if you had synchronous replication and a meteor cratered your primary data center, you still might have some recovery issues at that other site, and that the virtual machines would be shut down in an unclean state. But you would still have, theoretically, data loss of 0 seconds. The other type of storage replication that is in use is that of asynchronous replication. Asynchronous replication is needed for distances over a few hundred kilometers where latency is higher. And what happens with asynchronous replication is that the changed data blocks for your data stores are replicated at a staged interval. So maybe every 30 minutes or every couple of hours. So you can see that there could be an area of time here where if you had a failover event and it was in between those replication passes, you might be losing some data. So best practice is if there's time and you have a slow-moving disaster with some advanced warning, you'll want to manually shut down your protected VMs prior to doing one last replication pass before that failover. In this way, you can be assured that VM data is in a good known state and you have the latest and greatest data replicated to the recovery site. If time is not a luxury you have, then your last replication pass is going to be better than nothing. And your RPO in that case is going to be the time from the disaster back to the last replication pass. So, it could be anywhere from a couple minutes on up to the full time period of in between replication passes. Well, that's enough salad, Sean. Let's get to the meat and potatoes and demonstrate an actual failover, and I'll show you some of the key things you'll have to think about when initiating a failover. All right, we're going to be getting ready to do an actual failover here pretty soon before the power runs out, the asteroid hits our protected site, and the hurricane shows up. But what I wanted to show you is a little kind of caveat to keep in mind when you have asynchronous replication being utilized in your environment. In the case of our environment, we're using asynchronous replication with left hand, and one thing to think about there is that it means it's taking a snapshot in time every 30 minutes or so. In our case, it's every 30 minutes. Yours could be hours. But what happens in between those times, right? Or what happens prior to a snapshot happening? What if a disaster happened at that point and people are still in the system? Well, it's pretty simple. The data that didn't make it to that next replication pass would be lost. So your data would only be as good as the last snapshot. So in the case of a planned disaster failover, right? Maybe you're running out of diesel in your generator, or there's a hurricane that's slow moving that's coming and you have some warning. In those cases, you might want to take some special precautions to preserve your data. And that would be shutting down your critical virtual machines prior to doing that last replication pass, and then beginning to do the failover at that point. That way you know you have a good known state and the virtual machines won't have to go through crash recovery on the way back up. They'll be just like they went down for a normal routine reboot, except for the fact that they'll have to have their network address changed on the way up. So just to do that, or to demonstrate that concept, I'm going to remote into this critical PC, which I have right here. So I'm logged into the desktop of this thing. I'm going to go to the Z drive, which is a map drive to the critical file share. And you can see that we have our classic answer to life critical data here. It doesn't get any more critical than the answer to life, folks. So you can see that it's 42. But let's say we've declared a disaster and there's still users in the system and it's prior to that last replication pass. What if someone changed this to **88***? You know, this is an example. This is pretty far-fetched, but this is possibly representing your critical data, and someone could have created a new answer to life, right? Well, if they've changed that data, the thing that you have to be concerned about is what's the latest data for this disaster. And to get an idea of what this might look like in your environment, I'm going to actually log into the left-hand centralized management console here and kind of give you an idea. So we got this critical volume. Actually, it's the volume for my critical machines called VMFS1, and we have snapshots on there. The last snapshot in this case was 5:57 p.m., which was 15 minutes ago. Well, I'm not going to have another snapshot for 15 minutes, and I've changed some key data. So this is a perfect time to demonstrate what I was trying to show you. We're going to go ahead and do the failover before the snapshot has a chance to replicate that latest data, and you'll get an idea of what's going on. So I've switched over to the protected site so that you can see the virtual machines that are running currently, critical workloads, all of them, all three of them, let's say. And the first thing that failover plan is going to do is actually shut them down so that they're no longer writing data to the SAN. In our case, it doesn't do any good though, right? If we're going to begin the failover before that last replication pass has a chance to go, then we're not gaining much. In the case of a synchronously replicated SAN, where it's real time, that would help a lot. So the shutdown would stop any writes, and those would be replicated immediately to the other site. And once SRM began the recovery, it would be with a known good state for all of the data. So let's switch back to the recovery site. Here we are at the recovery site. We're going to initiate our failover plan. So this is the big red button. As you can see, a lot of big scary red hands telling you to stop. VMware does not want you to take this step lightly, and they put a few steps in here to make you think a little harder before doing this. I don't think any competent administrator would be able to click through this without without a little bit of thought. So big red hand, you don't ever see that. That's catches my eye right away. Also, there's a confirmation screen. You're going to have to actually click that you understand that this can't be undone and that this is a permanent shift to the recovery site. I understand those risks, so I'm going to go ahead and click that, and we're going to begin our recovery. So go ahead and click Run Recovery Plan when you're ready. Whew. Exciting. I hope you never have to do that in real life, though. I'm going to go ahead and switch back over to the protected site so you can see what's happening here. You can see we have 3 initiated guest OS shutdowns, and that's just what those first steps of the SRM do. It's actually walking through and shutting them down. It's already shut down, so nothing to see here, and they're already down. That was real quick. machines, which was successful. That's a good thing. We're now here at the preparing storage section, where we are taking the replicated volume, or SRM actually is, it's automating this. It's taking that replicated volume and transferring it into a primary volume. It's basically just changing the type of volume, since it is a very quick process. A lot of that magic is actually handled by the left-hand, or the HP left-hand VSA, and it's basically changing the personality of that replicated volume into a primary volume. As you can see, it's already presented it up to the ESX server at the recovery site, and it's now registered to virtual machines, and it's already gone through the process of booting them up and beginning to do the configuration steps. All right, right now the virtual machines are restoring themselves on the recovery site. I'm going to go ahead and roll back to home screen here so we can look at hosts and clusters, and we can see that they're on their way up. They're booting. We'll look at the console real quickly. And really what we're waiting for on the recovery side there is for VMware Tools to instantiate itself inside the recovered virtual machines and reestablish an operating system heartbeat. Once that's done, it'll be able to continue on with the next steps. Here it's to the step of changing the network address for the critical server. An item of note here is to note that we have two virtual machines started up simultaneously. That's the max that can be started per ESX server. Once one of those is finished, that last virtual machine there, critical PC2, will also start up and reconfigure its network and begin to become recovered. Okay, as we can see, critical server has completed its recovery. It's done its post power on, and the OS heartbeat has established itself. The same has been said for critical PC. And just like I said earlier, we've progressed then with the last virtual machine, which is critical PC2. All right, so now that you saw what happened there, all those task notifications, they just disappeared. And you might be wondering what happened. Well, we've had a successful recovery, and to prove it, we can go into history. We can take a look at the recovery plans here, where we have the ability to view what happened. You can see I've been having a little issues tonight. I'll go back. Quite a few errors, and we finally got a successful recovery. That's why it's good to test and test and test. So this is the report that you can hand your boss when you're done, or auditors, and basically say, hey, we had a successful recovery. All the virtual machines came out successfully. It also gives an execution time for how long each step took. That's really all there is to it. Recovering virtual machines. And one final step, which is verifying that those virtual machines were restored properly. So if I go back to the home screen and take a look, I can see at the consoles here, we have some virtual machines that have been recovered and logged. They're ready to go. They're logged in. And also to prove that the configuration worked, we can see that the IP address for a critical PC has now been changed from what was 62 to now 2.82. PC2 changed its address to .83. It was 63 earlier. I expect to see the same thing here with Mr. Critical Server. Again, yeah, 2.81. So We can see that the customization worked, and we've changed the recovered virtual machines to be the network identity needed at the recovery site. So that's all there really is to the failover. I'm going to go ahead and close out of this for a second and switch over to a remote desktop into that critical PC so that we can demonstrate that it did indeed restore data just like we wanted. Before we go into testing that everything worked, I about forgot one key step, and that is to make sure DNS has been updated properly. This could be scripted, or it could be maybe done through the use of DHCP. In our case, we're using static IP addresses and a DNS server that's not tied to Active Directory. So I need to come in here and update a few key records. There we go. That should do it. I'm going to go ahead and flush the DNS and verify that this is indeed working. Woohoo! Going to .81. Now I can test that the PC was recovered correctly. Hang on 1 second. All right, here we are logged into the critical PC that's been recovered successfully with SRM, and we're going to demonstrate that everything was recovered properly and that I still have access to my key files, or my critical file share, excuse me. And we have the answer to life. Well, just as I said earlier, we initiated the failover prior to the replication path completing that would have captured that last change data. So when you have an asynchronous replicated CN, you need to remember that there's going to be some data loss if you don't plan carefully. In this case, I think it's a small price to pay knowing that I have a few pieces of data that might be out of date, but I have my entire infrastructure restored in the matter of seconds, or actually in the matter of minutes, right? So think about the old school way of restoring that. We wouldn't even have been done loading the OS on the physical servers so that we could do a restore. We now have fully booted, ready to go virtual machines with all their data intact. That's a good thing. Well, that does it for this failover demo. It's good to see that we have a fully functioning set of virtual machines here at the recovery site and business is restored as usual. So with that, we'll move into our next section, which will probably be about failback. After you fail over to the recovery site, you have to plan to fail back to the primary data center. Unless, of course, you have the luxury of staying put and configuring a new recovery site. More than likely, we'll need to plan the failback somewhere. Since failback is technically another type of failover, then failover becomes yet another executive decision. This one is even more important than a failover decision when you think about it, because now you have a functioning recovery site that's working and everyone's been able to connect in and connect to their applications and do their job. But the question you'll have to ask yourself is, can you afford to fail back right now? Even though your business was saved by your superhuman SRM administration powers, this was a disaster. So there's probably some costs that were incurred surrounding the disaster event. This could be structural damage. This could be extra IT overtime costs to pay the super qualified IT staff. I sure hope you're getting overtime. If not, I apologize for rubbing salt in that wound. It could have been personal injury in the case of a tornado and people stuck in a building and hurt, or it could be fire damage. Whatever it was, your business has gone through a lot to get to this point, and it's up and running and paying the bills, hopefully being profitable. The last thing you want to do is toss a failback on the plate of an already stressed business. So we need to think about this very carefully. We'll also want to take a look here before we begin the failback and look at the design of failback at a very high level. There's really two things that are critical to this, and one is storage replication. You're going to be reversing the direction of storage replication from what used to be a recovery site. It's now going to become a new protected site. Hopefully this doesn't get confusing. But you're going to replicate back to the old protected site. You're also going to configure SRM in the reverse direction that it was configured previously. So that direction that you're configuring SRM is going to match the direction of storage replication. So you now have a new protected site that needs configured. You're going to have to configure a new recovery site in order to fail back. Knowing those two principles of failback, that it's storage replication and it's configuring SRM, you can basically apply the knowledge and principles that you've learned from the previous lessons to properly design your failback and execute it. Okay, we're now going to talk about failback scenarios for two main scenarios. One, where you've lost your entire protected site and there's nothing functioning there anymore. And two would be where the protected site is 100% intact and we're going to do a true failback. Now, first we're going to talk about where you have a total loss of the protected site. Technically, I don't see this as a failback. This is more of a failover to a brand new data center because we're going to be starting from scratch. We're going to be reinstalling Virtual Center. Before that, we're even going to be probably standing up a whole data center, bringing in servers, bringing in SAN. It really depends on the nature of the loss, but for all intents and purposes, it's a brand new SRM setup. The only work we're saving ourselves is that the recovery site has an already functioning SAN and VI environment and an SRM server. So one of the first steps you're going to do, and this is going to seem very familiar to earlier in the lesson, but we're going to be starting at the foundation of SRM and working our way up. We're going to set up SAN replication the same as it was before. So in the case of a total loss, our failback, we're not going to be able to save any bandwidth by having a lot of the data already pre-replicated. We're starting at scratch. So if you have a lot of data and you have a new SAN coming in, it's a good idea that you just locate that right next to the recovery site SAN. And then you can start your first replication pass to fill up all that data and all that protected VMs on that new SAN. Secondly, you're going to want to move the SRM license that was housed at the protected site. You're now going to want to put that at the recovery site, which is going to become your new protected site until you can get the failback completed. So we have SAN replication configured. We have the SRM license moved. Now we're going to configure SRM in reverse. So for this, I'm not going to show you again. I'm going to refer you back to your earlier lessons, but you're going to connect the two SRM servers. You're going to configure your inventory mappings. And before your inventory mappings, you'll configure your array managers, which is the SAN piece. And then finally, you'll do your protection groups. Once all that's done, you have your working SRM set up to fail back, so to speak, from the recovered site back to the primary data center. You're going to test, and you're going to test, and you're going to test. You're going to do the same things that I preached on before doing the failback. You're going to apply them again because this is truly another failover. Okay, now the other option that you have with failback is the case where you're executing failback to a functioning protected site. I really shouldn't say option because Murphy of Murphy's Law, he's going to dictate what your option is. But in this option, it's where the protected site is perfectly intact. And we're going to be restoring the recovered virtual machines at the recovery site back to the protected site, the original protected site. In this case, though, there's some stuff that's on that protected site that we don't need when we're doing a recovery. First off is protection groups. Those are no longer good. They've served their purpose. We've done the failover to the recovery site. They're no longer needed. The only reason you might keep them around a little bit is if you had poor documentation of what was actually protected and you want to go ahead and write down what the protection settings were so that you could configure them on the recovery site. We'll assume that you have that all figured out, so go ahead and delete those. You're not going to need them. Secondly, once the protection groups are deleted, you can go ahead and remove the old virtual machines from the Virtual Center inventory. However, don't delete them. We want to leave the storage intact as much as possible. We just want to remove the reference to the virtual machines from the ESX server and from the Virtual Center server. So once that's done, we can now prepare to get the replication configured. But before you do that, I would like you to power off the protected virtual machines at the recovery site. They're not actually protected yet, but they will become protected very soon. This is going to require a maintenance window to do, so go ahead and plan this for off hours or at night. You'd power off the virtual machines, and then as soon as that's done, proceed into the next step, which is reversing the replication of storage, or doing the failback of the storage replication. Not all SAN vendors support this. Quite a few do now, so you'll have to resort to their instructions on how to accomplish failback. In the case of left hand, we'll actually be doing the same steps you saw earlier to set up a replicated volume, except instead of creating a new remote volume, we're going to actually point to an existing volume, which happens to be on the protected VSA or the protected side SAN. So that's why you can see we don't want to delete the virtual machines, is we want that data to be intact so that the SAN's replication can work successfully and quickly. Once the SAN is been configured for reverse replication, you can go ahead and turn your virtual machines back on and end that maintenance window. Then you're going to proceed with the configuration of SRM, this time in a reverse direction to what it originally was. So the site that we've recovered to will now become the protected site, and we'll set up the first steps within the setup of SRM, which I'll show you fairly soon here in the demo. But if you remember, you configured the foundation, which was SAN replication or the array manager step. Actually, prior to that, you connected the two sites. So you connected the SRM site at the protected site to the SRM at the recovery site. Then you configured array managers. Then you configured inventory mappings. And then finally, you set up your protection groups and configured protection on your individual virtual machines. Once you're done with that, I'd invite you to refer back to the earlier half of this lesson where we talked about failback best practices and procedures. Because now that SRM's all configured and the SAN's replicated, you're ready to do a failover. We just call it failback because it's failing back to our original site. Again, this is a key time to remind you. You're in a functioning, working, recovered system. You're going to want to do this very carefully to minimize the impact to an already frazzled business. So dot your I's, cross your T's, and make sure you get it right. And testing is a big part of that. So with that, I think we're ready to begin our demonstration of failback. And in the demonstration that we'll be doing, we'll be failing back to a functioning protected site. Since I didn't have a hurricane, I just had a video demo to do. So we have a perfectly functioning protected site, or the site formerly known as the protected site, I should say. And it should be fairly easy to restart replication and show you what we need to do. So with that, hold on to your boots and let's do a failback demo. All right, things have quieted down now and we've been working successfully at the recovery site for quite some time now. Now it's time to start thinking about failback And in this case, we're going to do it immediately, just since we have a functioning site. Maybe the hurricane completely did a U-turn and there's no more disaster recovery pending. So we're just going to go ahead and restore back to the original protected site. But first, we need to do a little cleaning up. And right now we're at the recovery site, so there's not much to do here yet. But what we actually need to do is log into the protected site to clean up some old protection groups and remove the virtual machines from inventory. So let's go ahead and do that now. All right, I've logged back into the protected virtual center site with vSphere client, and we can see that we have some old virtual machines that we no longer need because they've been recovered to the recovery site. So we'll just remove the references to these. However, we want to delete the protection groups first. So let's do that. So to do that, we'll go to the home screen and Site Recovery Manager like we've been doing, and click on the protection group. What I like to do is remove protection first. And then once that's done, we should be able to remove the protection group. I just right-clicked on it and said remove, and then click yes. All right, now that that step's done, let's go ahead and clean up the virtual machines that we no longer need. And remember, we do not want to delete these because deleting it would affect the data on the data store. So we just want to remove them from inventory. That leaves everything intact on the data store. All it does is remove the reference in Virtual Center and removes the virtual machine from ESX servers as well. Cool, now that that's done, we can get into the next step, which will be setting up the replication to reverse itself and go from the recovery site to this, which is the protected site. That's going to be a little confusing for you. I'm going to continue to use the terminology that we've been used to for identifying the sites, especially since I've named them recovery and protected. So we're actually going to reverse the roles from an SRM perspective. So the site that has been used as the recovery site, we're going to configure it into a protected site according to Site Recovery Manager terminology. Bear with me a little bit. It'll be a little confusing, but I think it'll make sense. Okay, I'm back here at the recovery site. I'm going to go ahead and click on the hosts and clusters, and I'm going to shut down my virtual machines gracefully. The reason we want to do this is that we will be taking the storage from the recovery site. We're actually going to do the failover replication pass back to the protected site. So it's good that we can stop all I/O and all transactions to this recovery site VSA. That way we have basically a gold image being failed back. Remember, you're going to need to do this during a maintenance window, especially since I'm shutting down the virtual machines. You would not want to do this during the middle of the day. So a little planning would be in order. All right, well, I initiated the shutdown on all those, so now we are ready to begin the replication of the SAN. So let's hang on and do that in just a second. Okay, now we're logged into the HP Left-Hand Network centralized management console, and we'll be reversing replication of the newly recovered replica of the VMFS volume that we were replicating. To do that, we're going to start by clicking on the original volume. So this is the VMFS1 that's up under the protected group. And go to schedules, and what we're going to want to do is pause this schedule. I've already done this, so it's grayed out, but you'll want to do that now. The next step is going to be very familiar to how you set up replication on this volume originally, except we're going to do it on the replica. So go ahead and find the volume that's at the recovery site, and you're going to choose New Schedule to Remote Snapshot of Volume. This should look very familiar. We're going to go ahead and click the time. It's 11:13 now. I'm going to put this at 11:20 p.m. Just give me a little bit of time to finish this. I'm going to say never recur. Although if we were setting up replication to go over and over, you could set this at whatever you want for your recurring interval. Since we're just doing this for demo and we're ready to do the failback, we're just gonna do replication one time. Next, you'll get down here at the bottom, and as far as snapshots being retained, we're just gonna leave that at 1. Here's a key piece though. The remote snapshot group, we want to make sure that protected group is included. Go ahead and check this box to include primary volumes. What this will allow you to do is select VMFS1 from the drop-down. In your case, you might have multiple volumes. You'll remember in the first lesson for setting this up, going from protected to recovery, we came in here and created a new volume. We're going to go ahead and just select one that's pre-existing. This looks all good. I'm going to go ahead and click OK to begin the process of setting this up. This is just a notification that it's going to create a snapshot of that primary volume over there at the protected site, and I'm fine with that. We've already paused the schedule at the protected site on this volume, so this isn't a big deal. If there was one that was set up and it was replicating somewhere, it would fail because it now is going to be changed over into a remote volume. I'm going to go ahead and click OK. Let the wizard finish with setting up the scheduled remote snapshot. You can see that it immediately started a new snapshot. And now we'll be waiting for the replication pass to happen, which should happen in a few short minutes. Okay, it looks like replication is kicked off, and we have a great indicator of what direction that data is going. Earlier, you'll notice it was going down. Well, this is going up. So what's happening here is the primary volume that we recovered at the recovery site is now overriding the data of the primary volume at the protected site. Since we're doing failback to the original volume, it's only going to write the data that's changed since the failover, so it shouldn't be too much, so this shouldn't take too long. But either way, we'll pause recording the video until this is complete, and when it's complete, we'll finish on with the rest of the failback process. Well, we fast forward to the end of the replication, and it looks like it's complete. It didn't take very long since most of the data was already there, and we only booted up the virtual machines, so really the only thing that probably changed a little bit was the Windows page files stored within the virtual disks. So there wasn't too much that was substantially changed that needed replicated. Now we can actually proceed with the recovery, and we'll do that by logging into the recovery site SRM server. All right, well, now that site reciprocity has been verified again, we'll go ahead and configure the array managers for in this case, it's the recovery site, but it's the protection setup on the recovery site. So let's go ahead and click configure here. Please bear with me as we're going to have to do some mental gymnastics to keep the names straight. Here it's asking for the SRM protected site array managers, not the site that we called protected site, but the protection site that's local right now that we're trying to protect, which happens to be the recovery site. Confused yet? Well, just follow along. I'm sure you're fine since we're just reversing this process. So I'm going to enter in the array manager information for the recovery site since it's what we're trying to protect during this failback. As you can see, this is the same process that we did on the other site, the protected site originally, except we're going in reverse. So go ahead and click connect once I've entered in the information for the SAN that we're trying to protect. There's a volume there. I'll go ahead and click OK. And just like before, we want to make sure that device count says 1. If it doesn't, you probably did something wrong when establishing the replication back to the failback site. Since we got it a 1 in this device count area, we know that we have a replicated volume, so we can go ahead and continue. Here we'll need to enter in a recovery site array manager. This is going to be the array manager of the failback site, or in the terms of Prince, the site formerly known as the protected site. And to keep that straight, I'll give it the protected VSA name, which it had prior. If we were to log into the protected site right now and take a look at its array managers, we'd notice that these are just simply reversed as far as the configuration goes. So go ahead and click connect. Good, it sees the other side. Go ahead and click OK. You should be good to go. Replica of VMFS1, which used to be the remote volume for the protected site, but after we did the failover, we actually converted this to a primary volume for the recovery site. I'm going to rescan the array just to make sure everything's hunky-dory and we can see a volume that's replicated. Looks like we can see a data store. So there's a VMFS volume with VMs on it. We're good to go. I'm going to click finish and complete this step. And it's configured. Good. One more thing to do is inventory mappings, which I'll go ahead and click configure here. Again, you'll see that this is very similar to what we had to do in the previous lesson, in that we're going to be mapping inventory from what is now our new protected site back over to the original protected site. So I'm going to go ahead and zip through this. This is just an academic exercise to match up our resources. All right, well, I zipped ahead to save you a little bit of time, and I've configured the rest of the inventory mappings. That's pretty much the only thing that you have to do that's unique to this site. Now we'll go ahead and move ahead in the setup here. So if I click on site recovery so I can get my nice little connection of steps to follow through, you can see that we still need to configure protection groups. I'm not going to go through and complete the rest of this because you can already see that we're going to be repeating the exact same steps that we did earlier in the SRM configuration. So once we're done creating protection groups, we would then log into the site formerly known as the protected site, or what we're referring to now as the failback site temporarily. We would log into that site, and we'd have to create a recovery plan as well so that we can recover the failbacked virtual machines. There's not much that's different between this and a normal SRM setup. we've already demonstrated the pieces that are drastically different, which is the reversing of the SAN replication and some of the cleanup that had to be done before we could do failback. But other than that, you can take that information that you've already learned about configuring SRM and apply it in reverse to complete your failback. As you can see, demonstrating SRM and how it's used, once you learn those basic SRM setup and configuration skills, you can apply them in any number of ways to complete not only failback, but if you had to later on, you could also configure bidirectional SRM as well. As you can see that we're configuring SRM back to the original protected site, we could, in theory, leave a production setup replicating back this way and set up some additional volumes at the other protected site and replicate back to this site. So leveraging the knowledge that we learned earlier on how to configure SRM is something that you can leverage kind of like Lego blocks to build some pretty neat disaster recovery plans. Okay, well this about wraps up our lesson on failover and failback. But before we go, let's review what we've learned. We talked about how failover is different from a recovery test. A recovery test simply restores a copy of the virtual machines at the recovery site based on a replicated volume, and it doesn't affect production in any way, shape, or form. So you can do it anytime you want. Failover, however, does affect production. It's a permanent configuration change to SRM, and it affects production virtual machines by shutting them down. So you don't want to do that without having carefully thought out the consequences and without having talked to your executives. Failover is an executive decision. You don't have a lower end administrator making the call to fail over. It affects your business at many different levels, so you need to involve the top executives to make that call. We also discussed best practices for the planning and execution of a failover. One of the key takeaways here is that you need to test, test, and test. Even if there isn't a disaster, you should be testing this disaster recovery plan so that you can get the bugs worked out and your staff can get trained on how to execute it properly. When you have warning for your disasters, you might still have time to do some testing prior to doing that final failover. And that's one of the best practices we talked about. We also discussed the difference between synchronous and asynchronous replication and how it can affect your failover planning. Synchronous is real time, so as soon as you shut down your virtual machines at your protected site, you can begin your failover immediately and without any loss of data. With asynchronous though, there's going to be some thinking. Asynchronous is data replication at predetermined intervals. So if you have a disaster that's been maybe an hour since the last replication passed, you're going to lose an hour of data. So if you have advanced warning of the disaster and you can do this, it's a good idea to go in and shut down virtual machines and initiate that last asynchronous replication pass so that you don't lose any data. We also talked about failback planning for the storage and for configuring SRM. In a failback, you're going to be doing a lot of the same things you did to set up SRM in the first place, except we're reversing the direction, and that's the key takeaway here. Also, failback is yet another executive decision. And the reason that is that failback is a failover, except it's just in a different direction than you originally set up. So it should be taken very seriously, especially since you've just gone through a very traumatic experience for your business, and there could have been quite a bit of cost associated with that disaster. We don't want to risk adding yet more cost by doing a failback too soon and without the proper testing. We also talked about failing back to a functional protected site. So this is a site that had absolutely no structural loss, no data loss, at least at the time, and everything's ready to go. In that case, we're going to have to clean up some stuff that we no longer need since it's now a recovery site until the failback can be finished. So things like protection groups need to be deleted, and the VMs themselves, the references to the VMs, they need to be removed. but we don't delete the VMs because that can affect replication back. We also talked about failing back to a new data center. So in the case where your disaster is a fire and all of the systems in your data center are lost, we'll probably get that room, put down a new data center, and restore new equipment. In that case, we're installing brand new hardware, brand new servers, and installing fresh. And we can do some specific things to make that a little more efficient, like locating the storage at the recovery site so that it can replicate quicker. And then once that storage has been fully replicated, moving that SAN over to the new data center and then restarting replication. We've learned a lot, and I hope that you have a better idea for how to design your failover and failback systems within your environment. So this is all for this lesson on failover and failback. Thank you for watching, and we'll see you in the next lesson.